about half maybe. Okay. When I started at King's in 2002, I asked Aaron King, why are we selling corn? We're a perennial grass business, basically, with alfalfa. And, you know, whoever heard of Master's Choice, and the other one we were selling was Baldridge. And, you know, everybody knows Pioneer, DeKalb, et cetera, et cetera. And he responded to me, this corn is supposed to have digestible grain. It's a grain hybrid. Okay. So we didn't sell much. And we started to have feedback from some of the local farmers that they were using it for silage, and they were getting good results with us. Sometimes 3-4 pounds of milk per day type thing. And we're like, well, that's interesting, so why? We did test after test back then and really could not figure out why the corn made milk, but it was making milk. We immediately thought, wow, we must have really great fiber digestibility. Well, we had very good fiber digestibility, but not enough to explain the situation. So, I want to talk about mostly the new information. We're finally starting to get it figured out what's going on with this corn. So that's going to be the bulk of what I'm going to talk about. So if you have any questions, feel free to ask me as I go through. Just a little background on Master's Choice. They were started in 1978. It was basically, the breeder was bought it from the main company because most of the people got killed in the plane crash. And he was the survivor that had an interest in buying the company. So they are independently owned, and they do their own breeding of the inbreds. And when they were doing their breeding in the early time, the primary focus was on grain digestibility and sugars, using a refractometer to test for the sugar level. They do some real neat research on different things that most of your other corn companies don't do, and I'll end on the topic on a couple specialty products that are very interesting. So when you think about Master's Choice, the first thing you got to ask if you're evaluating corn, does it yield? If it doesn't yield well, doesn't matter how good it is. It needs to yield with everybody else or better. We think we're right there with everybody. You know, quite often we'll do well and win a plot, and then occasionally, or you know, it just goes back and forth. We're competitive. I'm not going to claim that we're 10% above everybody else or anything like that. How about management choices? What do I mean by management choices? If you go to a mainstream corn company today and listen to a talk, what do they talk about? Traits. And that's pretty much what they talk about. You won't hear me talking much about traits. I can talk about traits if you want me to, but we care more about the base genetics and do you need traits? In some cases, you may need a trait for a particular weed problem or an insect problem, but not all the time. So we do offer traits. It's certainly not our specialty, but we offer them, and it's not where my heart is personally. My heart is to set up a good cropping system that we do not need the traits. But there are times when you need the traits. So with that said, we do have traits, but we sell an awful lot of conventional corn. That's bulk of what we sell, and that's either treated or untreated for guys that are organic or natural. And then for the certified organic producer, we have the certified organic. So we do have management choices. And I'll also end on some of these specialty things, which is even different management yet. We have nutritional quality, and we have feeding efficiency. Right now, the price of feed, whether it's forage or grain, is pretty salty. We need to focus on feeding efficiency. Okay, as I said, they do their own hybrid development. So they take inbreds, which is a plant that is put together by breeding itself over and over and over again, and after about 7, 8 generations they get an inbred, and it becomes a weak plant, and they cross a male with a female, and then you get what they call hybrid vigor and get strong hybrids. So they do a lot of screening, mostly with their own inbreds, but they do buy in some inbreds from some other companies. As I mentioned, there was an emphasis, and still is an emphasis, on high sugar breeding. Not every hybrid has high sugars, but the majority of them do. And it gives you some special impacts in the field and nutritionally. So agronomically, a high sugar plant tends to be a flex plant. Does everybody know what flex is? You plant it far apart and it gets big long ears on it, wide stalks. If you plant them close together, it shrinks up. Okay? Most of the industry is doing what we call determinate or semi-flex ears, or if you plant them far apart, it's still the same basic looking plant. So that's a difference. Because of the high sugar in the plant, it has the ability to feed the roots better. So you get deeper and denser roots, which allows it to tolerate insect feeding a little better. Because we got that big root system, we can reduce the population and do the flex thing. We do have some insect tolerance, and that's mostly with the larvae only, and it's not all the larvae. That's an item where some insects is going to work and some it won't. It will not do anything for the beetle. Reliance on GMOs. Because we have these better items, we don't quite need as many GMOs or traits because of that. So that's the agronomy impact of the breeding program. How about the nutritional impact? When you have high sugars, you tend to have a dense stalk, a sweeter stalk. When you go to cut your corn, chop it off about a foot, 18 inches off the ground, taste the stalk, and then taste other hybrid stalks. You'll find a difference. Now, you do need to have good soil nutrition to pull these sugars out. If your soils are off, you can have a sweet hybrid that is not sweet. Quick fermentation. Because there's high sugar, it's going to rapidly ferment. And when it rapidly ferments, you lose less energy. And of course, sugar is highly digestible. Now, I wanted to just kind of think about nutrition with analogy here. You all know what a brick wall is, right? That's what your plant essentially is to the microbes. All right? And you have the mortar. What's the mortar do? Makes it bond together. All right. So we have a couple things. We have fiber, leaves and stalks that's made out of fiber with mortar in between it. And we have starch with mortar between it. What we find is that we have a little bit less of this mortar in the plants. And I want to explain that with some pictures and stuff. Remember I told you that the breeding program was first for grain, for digestibility of grain? Well, here's your standard corn kernel. All right, you have these sides that are the clear glassy material. That's called vitreous starch. The vitreous starch is this picture right here, vitreous endosperm. There's kind of like Rice Krispies where you got the marshmallow between. There's a lot of that marshmallow between, but it's not digestible. Whereas the white part is the floury starch, and there's less of that mortar in between. What prolamin is the yellow binding agent in the corn, and it technically is a low quality protein that encapsulates the starch, and it's water insoluble. Okay? It is not rumen degradable. If you reduce the prolamine level, you'll increase your starch digestibility. And that starts when you start to fill the grain. It's basically after milk stage. It's when the kernel is completely mature, it's loaded up pretty good. How about the fiber? There's these fiber linkages within the plant. And the Minor Institute is working on this actually, ester and ether bonds. It's how the fibers are laid down. In the case of the ester bonds, they're laid down more in a parallel method, and these ether bonds are more cross-linked, and a microbe can latch on to the parallel ones, or fungus, or whatever's in the rumen, all this biology. They can break this apart better than something's all twisted up. So that's what we're finding. They're working on a test, an NIR test. It's not done yet, but this is kind of the way they're going down. Now, the practical way to measure this is the NDF digestibility test. Okay, so I'm going to talk about that here in a little bit too. So remember I said it was bred for grain originally, but we found it makes good silage. What makes a good silage hybrid? Number one, high sugar, ferments better. Number two, that creates, goes hand in hand. High sugar, high fermentation. Here's the part that we really have a lot of. The grain part's digestible. And that's where the industry is just cranking up how to test for. They got a test now, trying to get it figured out. And we're seeing very good numbers with the commercial test. Fast fiber digestion. Okay, we also have that, and I'll show you more numbers on that. And then, of course, you got to have yield. A healthy plant with yield. So, in the lab, remember we talked about the new things. This isn't necessarily new, but this is over 8,000 samples from Cumberland Valley Lab, which is one of the good labs in the East. This is NDF digestibility. A low number is bad, a high number is good, and most of the samples make that traditional bell-shaped curve, and you want to be on this side of the curve for good forage digestibility. Now, does that mean anything financially? Let's assume $15 a milk, and they have this formula, milk per ton. It's kind of a made-up bunch of numbers. Doesn't really mean much for nutrition, but it gives you a relative idea how good something is. If we do math on that and plug in different fiber digestibilities, assume the other things are constant, we get these, almost 3,200 pounds, almost 3,400 pounds between the 54 and the 62. Plug in a value of $15 a hundredweight, we have a difference of $30 a ton in the theory of milk per ton, how much you get. And that's, again, a theory. A lot of nutritionists will tell me that when they plug it into a ration, you'll actually get a bigger difference. But we're using this number as a number. I don't know how much you feed, but let's say you feed 1,000 tons, which is a pretty good chunk. That's $30,000 a year. If you only feed 100 tons, that's $300. Now, how do we compare to the industry? This is another lab, Analab, which is the lab that Master's Choice does their breeding testing with. 150 samples that they sent in compared to the industry samples that they pulled in, over 12,000. We were 3% better in the NDFD, which that adds up. Okay, how do we do locally? Rod does testing and Micah with our dealers, and I'm just showing you a couple samples here so we don't overwhelm the slide. We have a couple established varieties, 490, which we're actually sold out of. There is a shortage in the seed industry this year, and 515, which we're sold out of. And we just sold out of that one too, but there's still a good bit. I'll show you what we have left at the end. But anyway, 490 and 515 are proven to be solid products up here in New York. We're in the same ballpark in milk per ton for these newer numbers that we have. Remember those numbers, 34 to 35, almost 36. Okay, but milk per ton, the important parts for milk per ton is right here. Okay, NDFD, pretty good in those. We're at that 60 range. I think I was saying 58 was good on the other slide. So we're on the right side of the chart. So here's where we're going. This is a 30-hour where most of the industry is. We're testing now at this level. That's the quick fiber. You want the quick fiber. Again, we were up here in those samples. How about the starch in the lab? Okay, remember, this is the yellow stuff, this is the white stuff. Floury grain versus standard grain, we lean more towards this direction. This is one of our hybrids, but they're not all this floury. And we have I don't think we have any that look like that. We're somewhere in the middle to there. But this, you want more this way, and that's affected by your climate. If you have a hot, dry, nasty year, you're going to have more of this. If you have a beautiful year, you're going to have more of this. Okay, starch. We tend to run pretty good in starch. 35 is considered a normal number for starch. We're usually above 35, but somewhere in that ballpark. But starch digestibility, you want to be in the 80s, somewhere in the 80 plus range. And it does depend on, these are silage samples, so it does depend on how dry it was when it was harvested and stuff like that. Another new thing, if you read the book, they talk about 5-carbon, 6-carbon sugars, and what in the world is that? Okay, that was my first response when the owners started talking about 5-carbon, 6-carbon sugars. I knew they existed, but what does it matter? Fructose, glucose, and sucrose are what we call the 6-carbon sugars. They're the ones that are burned up in fermentation. These are fermented samples. There's very little sugar left. That's the sweet stuff. Arabinose and xylose are 5-carbon sugars, and these are actually, and this is where it's important, the more of this, the better. They are the building block of the easily digested NDF. Okay, so they're the building block of hemicellulose, basically. And what we're finding is we are higher in these numbers than competitors. One other thing that we're looking at is mannitol, which is a sugar alcohol. It's a 5-carbon sugar alcohol that goes straight to the liver for energy. And what they're finding is this is a real milk maker, and there's big differences within hybrids, how much is being produced even within our lineup. So that's where we're screening now, is on the mannitol. And basically your pre-fresh to high milk producing cows really respond to mannitol. How do we compare to the industry? Everything I showed you was kind of internal data. This is using the World Dairy Expo. I don't know if it's valid or not, but we'll use it. Samples entered into the World Dairy Expo. This is the best of all the customers being sent in. Milk per ton, we're right up there on top. Now, there is not the BMR in here, but I'll show you a slide next one. So we're up there on top. Big difference in value with 100 tons, which is basically 5 acres worth of corn. Big difference. How many bags of corn does it take you to plant 5 acres? 2. So look at the difference in dollars between the top and the bottom, or the top and the middle. It's a difference. This is the 2001, another way of looking at it, comparing Master's Choice versus the BMR and the Mycogen TMF. They're all in the same category. They're all good, okay? Okay, how about, anybody feed their own grain? Okay, quite a few of you. How about feeding grain? Again, standard corn, floury corn. Again, we lean towards this. A floury, see these 3 kernels here? That's your standard corn. The one with standard vitreous and floury mix. Can you see this thing? That's light shining through. The floury doesn't allow light to go through. That's how they kind of get the name of vitreous. A glassy, you can put light through it. When you grind it, this is not the best of pictures in the world. You get a powder with the floury grain, and you get the chunks with the standard grain. Okay, what does that mean to the animal? We've had many farmer testimonies telling us with beef, they get faster gain. So Master's Choice hooked up with Southern Illinois University. Master's Choice is based in Southern Illinois. They did a preliminary test, and they fed out heifers to finish for beef to Choice. 84 days compared to not feeding any grain at all, 4.5 pounds. They knocked 32 days off of the time for the Master's Choice and 18 days off with the conventional grain. That's pretty significant. So we have an average daily gain of 15% higher with the corn that we tested here, which is our meat hybrids, versus elevator run corn. Kentucky 31 fescue, if anybody, you guys are up here where you don't need to grow Kentucky 31, but down in this deep south, they grow a lot of it. It's like the worst quality grass of any normal grass that's sold. So it was on a crappy diet under heat, and we saw that. With 4.5, what if you fed more? Didn't do any trials on it, but we assume it would be better. 100 bushels times 650 corn, 15% better feeding efficiency. Now that's a day, 35,000. And we're just throwing numbers out here. You got to put it on your farm to see if it gives you the same type of results. How about chickens? Anybody feed chickens? Couple? We were getting some comments on chickens as well. Not as many because not as many people feed chickens. They compared a couple of the hybrids versus standard corn. In this trial, which they had 12 roosters in each group, it was almost statistically significant. Not quite. They're going to run it again. It's a preliminary trial with more chickens, but basically more energy. About 40 to 50 kilocalories per kilogram. It means something, okay? Any organic growers here? Okay. Just want to mention organics. It took us a while to get the organics up and running at Master's Choice. I think it was 3 years till they even had a crop to sell. But they've got their act together now. We got 4 new organic hybrids. This one we're sold out of already, but we do have more. What do we have? Six of them. 6 organic hybrids. The goal is to keep on growing this. How about some specialty products? We have 2 specialty products. One called Lean Beef Maker, which is a male sterile corn. Basically, you plant it in a field without corn right beside it, and you'll get corn without grain. You have an ear on it with a couple scattered kernels on it from pollen blowing in. But basically, the leaves turn red, and it's real high sugar. And for people that are doing grass-fed beef, dry cows, heifers where you don't want the starch, It's making a good feed. Then we have this master graze, which is a corn designed to be grazed or harvested by haylage and baleage. Approximately 60-65 days be ready. It looks more like a sedan grass. It's all bushy, lots of tillers, and it has exceptional digestibility. It's a BMR, tonnage, good tonnage, 4-6 tons of dry matter in 60-65 days, and it's widely adapted. Our sorghum sedans don't like wet soil or cold temperatures, cooler temperatures. This goes where it's a little too cool for sorghum sedan. That's what it looks like when it's big. I wish I had a better picture of it. This is supposed to be a video, and it's not working, where a cow comes walking through grazing. I think I'll just jump there. Okay, this is what we have left. I mentioned that corn supplies are tight. We still have a good supply, but we're sold out of a lot of the base genetics that we built the company on. I showed you those slides earlier that these 4-digit numbers are brand new stuff, as good or better than the old stuff. So we actually have a good supply of some of the older ones and some of the brand new ones in both conventional, organic, and traded. Work with your dealer on hybrid placement. Some corns do better, can handle stressful soils. Other corns like real healthy soils. So work with your dealer for what works best on your soils. Any questions? And please feel free to jump in whenever. Raise your hand, yell.
When you go back to your slide in the starch and the sugars,
Okay.
5250 corn had the highest sugar. I think it was like a 3.2 in the last, the 6 sugar.
Okay.
The lowest in starches.
Okay.
Where would that place that hybrid make the milk?
Let's see if we can go back. Question was, looking at data, high sugar versus starch. Is that the basic question? Let's see, it should be coming up real soon. This one here?
That one and the one before that was
Oh.
like a 3.2 in the bottom.
Okay, starch we had 34 almost on this one, and the other ones were higher, okay, in the mid-30s. Where sugar, we have a little more sugar in this hybrid. They're both energy sources, okay? The sugar is practically all available. However, there's not much there compared to the starch. The cows are going to be the real story of how they milk. But that's the thing about nutrition. You can't look at one product. Quite often we'll get somebody say, well, will this replace haylage? Or will this replace corn silage, an alternative product? The products are what they are, and then the nutritionist needs to tweak the system around the product. So the idea is grow what best produces tonnage with as good of quality as possible, and then work your ration around it. That's the way we look at it. Any other good questions? That's a good one. Back here.
My understanding is that sugar is actually energy that isn't transferred into starch yet. And as the plant dries down, don't the sugar levels come down and starch levels go up?
That's correct. Okay. But how big is how much sugar's in the stalk? When you have a low sugar hybrid, by the time it made grain, that stalk's empty. It's a hollow tube, basically. A high sugar hybrid will have more in the middle, more of the pith. Okay, that's a general rule of thumb. As the plant makes grain, it cannibalizes itself. And then so what we find with the silage hybrids, they tend to have more of the guts of the stalk in them when you harvest it. And when you harvest that guts of your stalk, it packs better.
And that picture on
Oh. If I took my finger and pressed in this stalk, it's firmer. If I took my finger and pressed into that stalk, it's softer. This will empty out faster than that one. Okay, I'm probably out of time.